बेटा
बढ़िया सर, आप सुनाओ सर।
ओके गुड.
All set for question number 5, sir.
Okay, great beta. Last lecture we covered up some basics. We covered up altitude correction. We covered up the almanac information, then chronometer ambiguity. So today we are going to cover up few more basic concepts. Not cover up, refresh. You have already done them in pre-C as well as second mates. So we will be covering up the azimuth calculation, amplitude calculation, and then we will be moving into the first method of side solving, that is MARPAS, meridian passage, and then we cover the remaining ones. So that's the sequence which we are going to follow.
सर जहाँ तक मुझे याद है इसमें सबसे लेंदी लॉन्ग बैक रोन है ना, इसके अलावा कोई करीब
No,
70 लाख 80 लाख की हो जाए. एक सेकंड.
no, it is not lengthy. More or less all methods are comparable. MARPAS is slightly quicker. Other methods are more or less equal.
तीन ही है ना सर मेरे पास, लॉन्ग बैक रोन और टी सर वो आईटीपी वाला.
बेटा एक्स मेरिडियन और
इंटरसेप्ट,
पोलारिस.
एक्स मेरिडियन.
हाँ, और कौन से सर इस तीन के अलावा बताइए. पोलारिस और
You have MARPAS, long bicron, intercept, X meridian, Polaris.
ओके सर, ओके सर.
Okay, sir. Let's start.
Okay, beta. So we
Sorry,
are
sir,
already.
I have just joined. Can you please repeat what we were going through?
We did nothing, beta. Just asked about weather and all.
Okay, no, I heard something like Polaris and MARPAS. That's why I was asking.
That's what I told. We will be doing it now.
Okay, sir. We are ready.
Okay, great. Let me check if anybody is still struggling to join in.
सर एक छोटी सी रिक्वेस्ट थी आपसे.
हाँ बोलो बेटा.
मुझे लगा कि आप ही से कर सकते हैं. एट टाइम्स जैसे अभी आपने बोला कि लेट्स सी इफ समबडी इज स्ट्रगलिंग टू जॉइन और समथिंग, आप तो एक बार चेक करते हो, बट शायद कैप्टन विष्णु क्या करते हैं, वो सीधा क्लास चालू कर देते हैं सर. और देयर हैज बीन अ क्यूरियस फ्रॉम लास्ट 3-4 डेज अबाउट द लिंक व्हिच वी हैव टू गो. वैसे तो लिंक प्रिस्क्राइब्ड है कि अच्छा ये वाला लिंक जो है नेविगेशन चार्ट पर के लिए है और ये वाला लिंक स्टेबिलिटी के लिए है, बट कभी कभी हमारे एंड पे भी गलती हो जाती है. कभी कभी लाइक एग्जांपल यस्टरडे कैप्टन साहब के एंड पे गलती हो गई, उन्होंने किसी दूसरे लिंक में ज्वाइन कर लिया. सो जस्ट बाय द लुकिंग दैट टाइम 5:30 वी स्टार्ट एंड देन somebody is joining at the after 10 minutes, तो उसके लिए भी प्रॉब्लम है और जो प्रेजेंटर है उसके लिए भी प्रॉब्लम है, कि क्योंकि आपको भी रिपीट करना पड़ता है कि मैंने अब तक क्या बताया. तो फिर वो उसका थोड़ा सा आप एक बार सर विष्णु सर से एक बार बोल दीजिएगा सर प्लीज. हमने कुछ ना कल बोलने का, बट अब वो क्लास शुरू होके फ्लो में बात नहीं हो पाई ये वाली, तो हमें लगा कि आपको बता देना चाहिए.
Okay बेटा, okay, no issues. I'll pass on to him बेटा. He must be out of station. He must be outside
yes,
home.
Sir, he told us about this condition at his home.
Yeah, that's right.
Okay, sir. Okay, sir. We can start. I was just wanted to put it in your ear so that you can just help us out with something.
No issues, beta. I'll pass it on to him.
Okay, sir. Thank you, sir.
सर मैंने ग्रुप में क्वेश्चन शेयर किया है सर, ग्रुप में ना अभी जस्ट.
ग्रुप में बेटा. ओके, लेट मी सी. Let me show it here beta so that everybody can see. Is this the one beta?
Yes sir.
Okay, a composite great circle track from 33.0 to south so and so to so and so joins and leaves the limiting latitude of 50 degrees south in longitude so and so respectively. Calculate the total distance on this track. बताओ बेटा इसमें क्या डाउट आ रहा है?
सर ये मैंने सोल्व कर लिया बाय कोसाइन फार्मूला. सर मुझे डाउट ये जो लिमिटिंग लैट पे सर लॉन्ग दिया है सर वहाँ पे 90 डिग्री एंगल सर कैसे नहीं बनेगा सर? उसको हम सर नेपियर रूल से भी सोल्व कर सकते हैं सर।
ओके बेटा, ओके। बेटा इस क्वेश्चन में अगर आप ध्यान से देखो तो उन्होंने ज्वाइनिंग और लीविंग लिमिटिंग लैटिट्यूड की जो पोजीशंस हैं, बेसिकली जो
हाँ।
हमारे वे पॉइंट्स होते हैं, उनको फिक्स कर दिया है।
ओके।
नॉर्मल क्वेश्चन में तो हमें लॉन्जिट्यूड दिए नहीं होते, हम फाइंड आउट करते हैं।
हाँ जी सर।
बट इस क्वेश्चन में उन्होंने इन पोजीशंस को फिक्स कर दिया है। सो अब अगर फिक्स कर दिया गया है तो हमें इसी ट्रैक को फॉलो करना पड़ेगा, चाहे ये हमारा कॉम्पोजिट को प्रिंसिपल को फॉलो करता हो चाहे नहीं। हमें नहीं पता कि वर्टेक्स भी इन्हीं लोकेशन पे आएगा, वी डोंट नो।
ओके।
It is possible vertex may be here exactly in these locations, but we don't know, right?
ओके बट सर बाय नेपियर रूल सर आंसर सेम आता है, तो सर वो प्रिंसिपल मिस्टेक हो जाएगा सर पेपर में।
हाँ बेटा, because you see when the waypoints are fixed, तो फिर हम कैसे नेपियर रूल लगा सकते हैं? When we are applying the Napier rule, we are assuming that the angle is 90, which is not given here.
सर इस केस में सर जो मिडल सर जो है पैरेलल सेलिंग है सर, उसमें तो सर 90 डिग्री होगा ना इनर साइड ऑफ ट्रायंगल। सर वो तो कंफर्म है 90 डिग्री ना सर। सर जब
You are talking of the middle
जाएंगे
triangle, right?
वो पैरेलल सेलिंग सर, तो वहां पे तो इनर साइड ऑफ ट्रायंगल जो मिडल वाला ट्रायंगल है उसमें सर 90 डिग्री होगा ना सर।
मिडल वाले ट्राइंगल में तो 90 डिग्री ही बनेंगे बेटा, बट व्हेन ही द शिप रीचेज द मिडल ट्राइंगल ना at the waypoint, it may
Okay.
not be on 090, it may be on 085. When it reaches there, it will have to alter the course, जैसे हम वे पॉइंट पे कोर्स ऑल्टर करते हैं।
ओके तो सर इस केस में जो साइड वाला ट्रायंगल है उसमें 90 डिग्री नहीं बनेगा साइड में।
राइट बेटा, उसमें हम नहीं बनाएंगे क्योंकि हमें बताया नहीं गया। या तो वो लॉन्जिट्यूड ना देता, फिर तो हम वर्टेक्स ही निकालते।
हाँ जी सर।
बट since he has fixed up the longitudes, now we cannot contradict, otherwise
इसी
solution।
क्वेश्चन इसे सर सेम क्वेश्चन में एक सेकंड पार्ट वो ऐड कर दे कि फाइंड आउट लैटिट्यूड ऑफ सर्टेन लॉन्गिट्यूड, लेट्स से 180, फाइंड द पोजीशन ऑफ 180 लॉन्गिट्यूड। देन सर फिर कैसे करेंगे उसको सर? फिर जो साइड ट्रायंगल उसको हमको वर्टेक्स निकालना पड़ेगा सर।
बेटा देन इट विल बिकम कॉम्प्लिकेटेड, क्योंकि फिर आपको वर्टेक्स पहले निकालना पड़ेगा, फिर वर्टेक्स से ही इंटरमीडिएट पोजीशन आएगी।
ओके 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 सर।
आई डोंट
क्योंकि सर
एंटिसिपेट
ये
कि
सर
ऐसा
ये
क्वेश्चन बनाएंगे, वो अननेसेसरली कॉम्प्लिकेटेड हो
सर
जाएगा।
मैं कर रहा था तो सेम क्वेश्चन है, उसने 180 डिग्री लॉन्ग का लेट पूछा है बट उसने फिर ये नहीं दिया, ये पोजीशन नहीं दी उसने फिर वहां पर, तो फिर वो नेपियर रूल से हो जाता है सर सोल्व।
एग्जैक्टली बेटा, फिर तो आप वर्टेक्स जो है वो निकालोगे ही, अगर कॉम्पोजिट सेलिंग है उसी वर्टेक्स की हेल्प से फिर आप 180 पासिंग पॉइंट निकालोगे।
ओके सर, ठीक है सर।
So
ओके
the crux of this question is कि जो हमारे living और आपके joining latitude इन्होंने दिए हुए हैं, basically there are some points on that rhumb line, ऐसे assume करके using cosine triangle we can solve it, correct?
दैट इज राइट बेटा, दैट इज राइट।
We will not assume that it's a vertex because
Yes, बेटा,
ऐसा कुछ mandatory नहीं है।
that is right. We cannot assume that because no hint is given in the question that this is a vertex. और अगर vertex ही होता तो he would have easily told us to calculate the vertex. So then it would be a straightforward question. But since positions are fixed, we go by these positions. So basically, you are asking that in a spherical triangle, you want to find whether the vertex is inside or outside. You calculate first angle. Let us say you calculate angle A, it becomes obtuse. Then you can stop your solution there. If you have a obtuse angle, vertex will be obviously outside and on that side angle. Means on it will be towards that particular angle. Two angles in a PAB triangle, angle A and angle B cannot be obtuse. Only one of them can be obtuse. There could be two options, either both are acute angles, or the second option is one of them is obtuse, other one is acute. Both of them in a PAB triangle cannot be obtuse. So if you find one obtuse, solution matter ends there. You don't need to find the other angle.
Can we decide by checking by P, sir?
नहीं बेटा,
P?
नहीं, कोई इंडिकेशन नहीं मिलेगी आपको, so आपको फाइंड करना ही पड़ेगा एक एंगल.
Sir,
कम
then
से
in the question number 6, which one you have given the assignment, so we just have calculated only the P and D long initially, nothing else. So how we came to know that vertex is lying outside this triangle?
नहीं
So
बेटा,
then
ढूंढने पड़ेंगे एंगल्स तो ढूंढने पड़ेंगे बेटा, तभी वर्टेक्स बाहर है या अंदर है उसका पता चलेगा.
So then we have shifted to the GC great sailing this question number 6. Typical.
Okay. So now you are talking of a composite question, that too special type, when the limiting latitude matches with the latitude of a port, right?
Yes, sir.
Right. अब बेटा जो मैंने अभी बताया ना, दिस वाज फॉर ए स्फेरिकल ट्रायंगल PAB, जिसमें GC सेलिंग कर रहे थे हम. जब आप कॉम्पोजिट सेलिंग करते हो तो उसमें तो बेटा वर्टेक्स की पोजीशन हम पहले निकालते हैं ना, उसमें एंगल ए भी थोड़ी ही निकालते हैं, उसमें तो नेपियर रूल लगा के सीधा वर्टेक्स की पोजीशन निकाली जा सकती है. समझे आप बेटा, दोनों में मेथड अलग अलग है.
Yes, sir.
डिड यू गेट इट?
ओके सर, बिकॉज सोल्यूशन के अंदर वो सीधा किया हुआ था तो इसलिए थोड़ा कंफ्यूजिंग था, बिकॉज जीसी के लिए शिफ्ट किया होता उसने. तो
कॉम्पोजिट के जितने भी क्वेश्चन होंगे बेटा, कॉम्पोजिट के, उनमें जो भी स्फेरिकल ट्रायंगल बनेगी, उन स्फेरिकल ट्रायंगल में वर्टेक्स का लॉन्जिट्यूड डायरेक्टली निकाला जा सकता है, और वर्टेक्स का लॉन्जिट्यूड देखते ही आपको पता चल जाएगा कि वो अंदर लाई कर रहा है या बाहर. दिस इज एप्लीकेबल टू कॉम्पोजिट सेलिंग. जीसी सेलिंग में वर्टेक्स पहले नहीं निकलेगा, आप पहले एंगल ए और बी फाइंड आउट करोगे. ऑब्ट्यूस है इनमें से कोई एक एंगल तो वर्टेक्स बाहर बनेगा टूवर्ड्स दैट एंगल, अगर दोनों एक्यूट हैं तो अंदर बनेगा.
yes sir, that's right.
ओके.
And so the same can be determined by looking at the quadrant also, no, for the initial course and the final course. In the instructions, it is given that we can
बेटा
make out
मैं
if the vertex
क्वाड्रेंट को
in the same
अवॉइड
quadrant
करूंगा,
it is between.
मैं क्वाड्रेंट को अवॉइड करूंगा, दैट कैन बी कंफ्यूजिंग. ओके, गो बाय द एंगल्स, इट इज द सिंपलेस्ट पॉसिबल वे. क्वाड्रेंट में आपको कहीं कभी डाउट हो सकता है. इफ यू आर कंफर्टेबल यू कैन गो अहेड, आई हैव नो इश्यूज, but I would recommend doing it with angles. That is the simplest way.
Sir,
Okay.
sir,
Means
one
we have to
request.
calculate and show. In the
Yes,
answer
you
sheet,
need
we have
to
to calculate and show.
That is right, beta.
Okay.
Sir,
Sir,
one
sir,
request.
सर
Go
जो ये
ahead.
ग्रुप पे क्वेश्चन शेयर किया ना, एक बार सर फिर से उसको एक्सप्लेन करेंगे क्या? एक्चुअली मुझे अच्छे से समझ में नहीं आया.
Okay. बेटा आपने उसको ट्राई किया? राज, आपने उसको ट्राई किया बेटा?
नहीं सर, ट्राई तो नहीं किया, लेकिन क्वेश्चन देख के मुझे
फिर
ये
बेटा
समझ में आया कि
होल्ड
उसका
ऑन,
limit-
कोई बात नहीं, होल्ड ऑन. फिर मैं यहाँ सारा क्वेश्चन करूंगा, उससे अच्छा है कि आप एक बार उसे ट्राई करो. जहां पे आपको डाउट होगा आई विल एक्सप्लेन दैट बेटा.
Sir, can you please send that video, which is get brief about GC, sir? That YouTube video link.
फॉर जीसी सेलिंग बेटा?
Yes, sir, for GC selling. That link only, sir. So we can just recall it.
आशीष वो ना मरीन गुरुकुल यूट्यूब पेज पे ना सारे ज्यादा वीडियोस नहीं है, सारे वीडियोस बहुत अच्छे हैं, उसमें इजीली मिल जाएगा. मरीन गुरुकुल पेज सर्च करना यूट्यूब पे, मिल जाएगा बहुत आराम से.
Exactly. So
Okay,
beta
भाई,
just
okay.
go
वरना मैं
there.
इसको check कर दूं.
All are there बेटा.
सर एक चीज और बता दीजिए बस, जो क्वेश्चन सर आपने अभी शेयर किया था, इसने जो शेयर किया था ना सर, तो सर उसमें बस जो हमने कंसेप्चुअली पढ़ा था अबाउट कंपोजिट सेलिंग, तो सर जो हम लोग जहाँ पे सर जहाँ पे वो काटता था सर लिमिटिंग लैटिट्यूड को, दैट वाज द वर्टेक्स, राइट?
Right.
और एक साइड से वर्टेक्स आता था और दूसरे साइड से भी सर जो हाईएस्ट लैटिट्यूड होता था, हाईएस्ट
Right.
पॉइंट होता था, वो वर्टेक्स होता था.
Right.
इस क्वेश्चन में इन्होंने ऑलरेडी दिया हुआ है कि ये पॉइंट पे लिमिटिंग लैटिट्यूड को इट इज कटिंग, करेक्ट सर?
बेटा क्वेश्चन हमें पता है, आप डाउट पूछो.
मैं ये पूछ रहा हूँ सर, तो ये हम लोग क्यों नहीं अज्यूम कर सकते कि जहाँ पे उसने काटा है वो वर्टेक्स ही है सर?
बेटा हम अपनी तरफ से अजम्पशन कैसे कर सकते हैं? वी कैन नॉट.
तो क्या सर जो हमारा ट्रैक है वो एक से ज्यादा पॉइंट्स पे काट सकता है क्या सर? जो ये है सर इसको लिमिटिंग लैटिट्यूड को।
Okay, beta, I'll tell you now. Let us say practically you are doing composite sailing on boat, right?
यस।
अब जब आपने ये composite sailing की, आपने पहले जैसे हम बिल्कुल करते हैं composite वैसे ही की, दोनों vertex निकाले, vertex की
जी।
पोजीशन आ गई, अब आप चार्ट पे चले गए, आपने प्लॉट किया, राइट?
जी।
जब आप प्लॉट कर रहे थे तो आपने देखा जहां मेरा वर्टेक्स आ रहा है वहां पे एक आइलैंड है, छोटा सा।
जी।
अब आप उसके ऊपर से तो नहीं जाओगे, आपको शिफ्ट करना पड़ेगा,
जी।
राइट? तो
यस
आपने
सर।
वो जो लैटिट्यूड या वो जो पोजीशन थी, जो वे पॉइंट था, उसे थोड़ा सा ईस्ट या वेस्ट में शिफ्ट कर दिया ताकि आप उस आइलैंड से क्लियर हो जाओ,
यस सर।
राइट? नाउ दैट पॉइंट विल नो मोर बी वर्टेक्स
यस सर, करेक्ट।
and the
करेक्ट।
triangle has to be solved using cosine formula now.
ओके सर, गॉट इट।
This
गॉट
is
इट।
what is done.
ओके।
Excuse me, sir.
Excused?
In question number 6, I calculated the angle P and it came negative. So, while you said that when P will come negative, then we can know that vertex is outside the PAB triangle. So, with that, we can assume that this is the, we can calculate with the GC.
Perfect, beta. You can. You get that angle, you just write composite not applicable, switching over to GC and solve.
So one more doubt, sir. Same question number 6. For my triangle, the P came 0.
Beta, there is some mistake in the calculation. There is some mistake in the calculation. So you work out the spherical trigonometry triangle. Okay, the spherical triangle, not the rhomb line triangle. स्फेरिकल ट्रायंगल को नेपियर रूल से वर्कआउट करो, यू विल गेट द करेक्ट पी।
नहीं सर, मैं इनर एंगल मैंने क्या किया था, वर्टेक्स अंदर एज्यूम किया था, तो ट्रायंगल PAB1 बन रहा था, उसमें जब एंगल P में निकाल रहा था तो मेरा P 0 आ रहा था, तो इसका ये मतलब था जो मेरा वर्टेक्स है इट इज लाइंग ऑन द इनिशियल पोजीशन में। तो मैंने फिर रम लाइन से सॉल्व किया, मैंने माय आंसर इज मैचिंग। सिंपल, सॉरी रम लाइन कह रहा हूँ, सिंपल GC ट्रैक से मैंने
बेटा इट विल नॉट कम 0, वर्कआउट अगेन, वर्कआउट अगेन, ये 0 नहीं आएगा बेटा।
एक्सक्यूज मी सर।
ओके सर,
बोलो बेटा।
सर ये क्वेश्चन नंबर 16 में जो सॉल्यूशन दिया है सर, इसमें कंपोजिट ट्रैक में केवल 2 ही ट्रायंगल बनाया है, पॉसिबल 2 ट्रायंगल?
I'll have to see beta, just give me a minute, let me open up. You are talking, let me open up the assignment. बेटा ये लास्ट डाउट ले रहे हैं, इसके बाद थोड़ा सिलेबस कवर अप करेंगे, बाकी के डाउट्स बाद में लेंगे।
यस सर, करेक्ट सर।
That's right. You are talking of question number 16 बेटा?
यस सर।
Here it is beta, this is question number 16.
Yes.
Please tell me the doubt.
सर यहाँ पे केवल 2 ही ट्रायंगल बने कंपोजिट ट्रैक में, इट इज पॉसिबल ट्रायंगल बिकॉज़ फ्लैट भी दिया।
बेटा you are coming broken, can you speak clearly and slowly?
सर ये कंपोजिट ट्रैक में केवल 2 ही ट्रायंगल सॉल्यूशन में बना के सॉल्व किया है, क्या ये पॉसिबल 2 ट्रायंगल बने? जब हमारे पास लिमिटिंग लैटिट्यूड भी दिया हुआ है तो हम 3 ट्रायंगल बन सकते हैं ना?
नहीं बेटा, जहां पे भी आपका लिमिटिंग लैटिट्यूड किसी पोर्ट के लैटिट्यूड से मैच करेगा वहां पे सिर्फ 2 ट्रायंगल ही बनेंगे। गॉट इट बेटा?
यस सर।
ओके, ऑल राइट। सो बस बेटा अब बाकी के डाउट्स वी विल टेक अप लेटर। सो नाउ वी आर गोइंग इनटू द टॉपिक फॉर टुडे। तो as I told you, we will be first covering up the amplitude and azimuth calculation and then further. So let's go beta. Just give me a minute. Let me open up the set up the presentation. So going into the, just a minute. So going into the azimuth calculation first by ABC method. Let's go. Let's now refresh the calculation of azimuth of the celestial bodies using the ABC method. Now in this method we calculate the three components A, B and C, and this helps us to calculate the azimuth of the body. The azimuth is basically the bearing or the direction in which the body is. A is given by tangent of latitude divided by tangent of P. Latitude will be given to us in these questions, so that same latitude is used here, and the value of P is obtained from the LHA. This P is basically angle P of the PZX triangle, which is made on the celestial sphere. And this P is either equal to LHA or it is equal to 360 minus LHA. Now, in which case it is equal and in which case it is 360 minus LHA? If the value of LHA is less than 180, the value of P is equal to the value of LHA. And if the value of LHA is greater than 180, the value of P is 360 minus LHA. In any case, the value of P will never be greater than 180 degrees. Now, once you calculate the magnitude of A, we have to give it a name. The naming is either north or south. Now, let's understand how the naming is done. This A factor is named opposite to latitude if angle P is less than 90, or if the value of LHA is greater than 270 and less than 090. So you can remember any of the conditions which is more comfortable and convenient, easy to memorize for you. The factor A will be named opposite to latitude if the value of P is less than 90, or if the LHA is greater than 270 and less than 090. And it is named same as latitude if the value of P is greater than 90, or the value of LHA is greater than 90 and less than 270. So as mentioned earlier, you can remember any of the two conditions. Either you can correlate it with the value of P. P less than 90, it will be named opposite to latitude, and P greater than 90, it will be named same as latitude. Or you can correlate it with the LHA of the body. If the LHA is greater than 270 and less than 90, it will be named opposite to latitude. And if the LHA is greater than 90 and less than 270, it will be named same as latitude. Now you will observe that in most of the questions, the condition which will apply will be the first condition, condition number 1. That is named opposite to latitude if P is less than 90 or LHA greater than 270 and less than 90. So in most of the questions you will have the first condition given to you. A doubt may arise in your mind that what if the value of P is exactly equal to 90? Or in other words, the value of LHA is exactly equal to 90 or 270. So how are we going to find the direction of A? Now, if the value of P is equal to 90 degrees, the A value in this formula, you can see here that the value of A would become 0. You can understand it very easily. Tangent P can be broken down as sine of P upon cos of P. The cos of P component will come in the numerator, and in case P is equal to 90, cos of P becoming cos 90, which is equal to 0, will convert the whole factor to 0. So the A factor or the value of A would be 0 in that case. So you will not need to name it either opposite to latitude or same as latitude. So this was the formula for A. Go ahead, beta.
Tan 90 is infinity, no, but
1 upon infinity is 0 again, beta.
correct. So won't exist here.
Okay. Let's move to B now. Now let's proceed ahead and see the formula for B. Go ahead, beta.
सर आपने जो ये बताया सर LHA greater than 270 and less than 90 सर ये तो इसको सर आप एक बार सर डायग्राम में बना के बता सकते हैं सर ये कंफ्यूजिंग रहता है सर बहुत हमेशा मेरे को
बिल्कुल बना देंगे बेटा but it is not required now. You can just forget about the diagram, not needed now. Later on I'll tell you how it is shown in the rational horizon diagram.
Okay sir.
Okay. Now B is calculated using the formula tangent of declination divided by sine P. Now P, as I told you, will be calculated from the LHA of the body. If LHA is less than 180, P is equal to LHA. If LHA is more than 180, P is equal to 360 minus LHA. How would we obtain the LHA of the body? It can be easily obtained from the GHA, which is given in the almanac. You will obviously be given a particular time on which the azimuth is required. So for that time, you can get the GHA of any celestial body, sun, star, planets, and moon. For all these bodies, the GHA is obtainable from the almanac for every day, hour, minute, and second of the year. So you obtain the GHA of the body from the almanac. You apply the longitude of the observer, which is given in the question. And when you apply the longitude to GHA, you get the LHA of the body, and that gives you the value of P. The numerator contains declination. Declination is obtained directly from the almanac. So as I told you, the date and time of the observation is provided to us in these questions. So with that date and time, we can enter into the almanac and get the declination of any celestial body. The declination as well as the GHA of all the celestial bodies, sun, stars, planets, and moon is obtainable, available to us in the almanac information. So this is the formula for B, and the naming for B is very, very simple. It is always named same as declination. So once you calculate A as well as B, now you can combine them to obtain the value of C. Now how do you combine them? C is obtained either by A plus minus B or B plus minus A. Now which of these is to be used in a particular scenario? If the value of A and B is of the same name, we have named both of these factors. A is named basis this criteria, opposite to latitude or same as latitude. B is also named same as declination. So if you find that both A and B are of the same names, you add them and obtain the value of C. If A and B are of the opposite names, then we subtract the smaller one from the bigger one and retain the name of the bigger one. So same names are to be added, opposite name, the smaller one, is to be subtracted from the bigger one. The naming of C is done if both A and B are of the same name, the C is also of the same name, and if A and B are of the opposite name, C gets the name of the bigger value, whichever is greater between A and B. So this is the formula with which we can obtain C. Once C is obtained, then we can use it in the azimuth formula. So any doubt up to here, beta?
सर ये ए में हमने पी की वैल्यू कैलकुलेट करी थी, ये भी वही सेम ही तरीका है ना सर जो बी में कैलकुलेट करी थी?
Exactly, beta. Exactly same. Okay, great. So moving ahead now. We will just see the azimuth formula in the coming slide. Now, another doubt which may arise in your mind is that we do these calculations using the scientific calculator. So sometimes if you want to write down these values, to how much accuracy we should note these values down. So value of A, value of B, and then value of C. You can do that in the calculation. The entire formula can be solved in the calculator itself, giving you the maximum accuracy possible. But for writing down in your answer sheet, you can write these values up to 5 places after the decimal. So when you are writing them down, no need to write down the full value. That will be unnecessarily lengthy and complicated. We will get our required accuracy by going to 5 places after the decimal, and the accuracy would be sufficient for our purpose. Now, once the value of C is obtained, then we can use this formula. Tangent of azimuth is equal to 1 by C into cos of latitude. C is what we have just calculated from combining A and B, and latitude is given to us in the question. So using these two values, we can obtain the azimuth of the body. So this is the last formula which we use after A, B, and C. Now, when we calculate the azimuth using this formula, important thing to remember is that azimuth is obtained in the quadrantal notation. It is not obtained in the 3-figure notation or true notation. It is obtained in the quadrantal notation. Now, in quadrantal notation, whatever value you obtain has to be prefixed by either north or south, and it has to be suffixed by east and west. You will have the north-south name before the value, and you will have the east-west name after the value. So the formula is going to give us the value or the magnitude of the azimuth. How do we now decide whether it is north or south in the beginning and east or west in the end? Or in other words, how do we decide what is the quadrant in which the azimuth lies? Now this is also very, very simple. The north-south value to be written in the beginning is decided by the name of C. Remember, I told you when we combine A and B, if both are of the same name, the name of C is also same. The name is same as A and B. If A and B are of the opposite names, C gets the name of the bigger value. So whatever is the name of C, the same name is used in the beginning before the value, either north or south. And the ending part, east and west, is decided by the LHA of the body. So we had already calculated the LHA of the body for finding the value of P to be used in the formula. So this value of LHA tells us what alphabet has to be used in the end, whether it will be east or west. If LHA is less than 180, it will be west, and if LHA is greater than 180, it will be east. This is because LHA or local R angle is a westerly measurement. It is measured westward from the observer meridian. So if the LHA is less than 180, it denotes that this particular body is west of the observer. And if LHA is more than 180, then it denotes and indicates that the body is east of the observer. So this is how we decide the quadrant in which the azimuth lies.
Sir, can you represent diagrammatically, sir, how it is? I have some doubt for imagination actually.
No problem, beta. We will do it, but it is not required now. Now I'm emphasizing on the calculation. I will do it in detail. Don't worry. We will make it on a rational horizon diagram and I'll explain to you in detail.
Okay, sir, thank you.
You will not need it now. When it is required, I'll explain to you.
Okay, sir.
Okay, so any doubt in the calculation, beta? Any doubt in getting the answer here using these formula?
No, sir.
No, sir.
Very good, beta. Great. So let's move ahead. Now, when we work with celestial navigation questions involving R angles, by R angle, I mean the local R angle, LHA, Greenwich R angle, GHA, or sidereal R angle, SHA. You may sometime be faced with a tricky situation. What happens during calculation that the value of these R angles sometime goes into negative, and in other cases the value may go beyond or more than 360 degrees. Now what is to be done in those cases? Now sometime candidates get confused of how to get these R angles correctly. So that's why I always emphasize it. The value of R angles, whether it is Greenwich R angle, GHA, or local R angle, LHA, or sidereal R angle, SHA, you can also consider right ascension. Right ascension is something which is opposite to SHA. SHA is measured westwards. Right ascension is measured eastwards from the celestial meridian of Aries. All these are R angles. Now their value always remains between 000 and 360. The value of R angle will always lie between these two figures. Now in any of the calculation, if you see that the value of R angle has gone outside this range, that means either it has become negative, less than 0, or it has become greater than 360. Now how to bring it back? You can add or subtract 360 degrees any number of times as you require to bring it within this range. So if the value of R angle is minus 60, you have to add 360 to it and you will get the answer as 300. If the value of R angle is, let us say, 740, it has gone beyond 360 range, it is more than 360, you subtract a 360. If after subtracting 360, still the value remains outside the range, you can subtract 360 degrees again. That is why you see it is mentioned any number of times. 360 degrees can be added or subtracted any number of times till you get the R angle value between these figures of 000 and 360. So any doubt in this beta?
No, sir.
Very good beta, great. Let's move ahead. So very important relationship. Please keep in mind that always 360 is to be added and subtracted. We do not add 90 or 180 or 270. Any of these figures are not added or subtracted. Otherwise, the calculation will go wrong. We always add 360 and we always subtract 360 only. So if you keep this in mind, you will not get stuck with the R angle calculations and you will get the right answers. Now let's refresh the calculation of amplitude. Amplitude is basically the azimuth or bearing of a body when it is on our horizon, or you can say when it is rising or setting. Now the formula for amplitude is sine of amplitude is equal to sine of declination divided by cos of latitude. So in these questions, the latitude is provided to us in the question, so it can be straight away picked up and used, and the value of declination is obtained from the almanac, and just by a single step formula we obtain the value of the amplitude. Now we have to be careful that the value of amplitude which we obtain is obtained in a special format, and that format is you will have a east or west in the beginning and you will have a north or south in the end. We do not use this type of format in any other calculations. The format which is generally used in the quadrantal notation has the north-south in the beginning and east-west in the end. But in the calculation of amplitude in this particular formula, you will have the east-west coming in the beginning and north-south coming in the end. Now, when you get the value of amplitude from the formula, you get the magnitude. Now, how to find out the name, whether we should put east or west in the beginning and whether we should put north or south in the end? How is this to be decided? This is also very simple and easy. Now, whether we should put east or west in the beginning is decided by whether the body is rising or setting. In case of rising, it will obviously be east. All the celestial bodies rise on the eastern horizon, and in case of setting, it will be west. All the celestial bodies set on the western horizon. The north or south to be put in the end is decided by the declination of the body. Whatever is the name of the declination, the same north or south indication is to be put at the end of the amplitude. So this is the amplitude formula and the related information about how it is to be named. Now in amplitude questions, usually the time of observation is not provided to you. In the azimuth calculations, I told you that date and time is provided in these questions because the azimuth will keep on changing as the time passes. But for amplitude questions, usually the time is not provided to you. So how do we obtain the declination of the body? Because for declination, we require the time. So what we do is we first obtain the LMT of rising or setting of the body from the almanac. So we obtain the LMT of rising or setting from the almanac. Then we apply the longitude and time. DR longitude is provided to us, so we divide it by 15. That gives us the longitude and time, and we apply it to the LMT to obtain the GMT of rising or setting. Once the GMT is obtained, with that GMT we can easily enter into the almanac and get the declination of the body, and this can be then applied, used in the formula. So these are the steps which are involved in the amplitude calculations. Practically, we only use the sun for amplitude purpose. No other celestial body is practically used for amplitude calculation. Other bodies are stars, planets, and moon. Stars and planets, why they are not used is because they are point objects, and usually we are not able to clearly observe them when they are rising or setting or they are close to the horizon. So they being point objects, difficult to observe when close to the horizon. So that's why not used frequently for amplitude observations. And in case of the moon, why is moon not used for amplitude? In case of the moon, when you see the moon rising or when you see the moon setting, by the time we see the moonrise or moonset, the occurrence has already occurred, means the moon has already come above our rational horizon. By the time we see the moon, it has already attained some positive altitude. Now, how is that possible? When the moon rises and we see it immediately, how has it attained a positive altitude? The reason lies in that we observe the moon using the visible horizon, but the amplitude is taken basis the center of the moon on the rational horizon. Now, in case of the moon, the rational horizon is below our visible horizon. So that's why when the moon comes on the visible horizon, it has already crossed the rational horizon and its amplitude is practically not possible. The second difficulty which we face with the moon is that because of the phases, the shape of the moon keeps on changing. Sometime it is gibbous, sometime it is crescent. It could be a full moon day or new moon day. So if the size is anything less than half, it will be difficult to get the exact bearing of the center of the moon. So that is another difficulty which we face while taking the amplitude of the moon. So I'll explain to you why amplitude of moon cannot be taken. So I'm moving on to the next slide. Any doubt in this, beta?
Sir, can you explain that when we observe the moon in visible horizon, it has been already crossed to the rational horizon, so that we are unable to locate that, right, sir?
Okay, beta, I'll explain that. I'll explain.
Sir, I also have one doubt.
Go ahead, beta.
हमने मून का इसलिए यूज नहीं किया क्योंकि जब हमें वो दिखा तो उसका रैशनल होराइजन उसका जो सेंटर है वो ऑलरेडी रैशनल होराइजन को क्रॉस कर चुका है. तो प्रैक्टिकली व्हेन वी आर ऑन शिप तो हम बेसिकली एम्पलीट्यूड सिर्फ सन का ही लेते हैं हमेशा राइजिंग सेटिंग पे.
That's
तो
right, beta.
हम सन का एम्पलीट्यूड किस पॉइंट पे ले सकते हैं? हमें कैसे पता लगेगा कि सन का सेंटर अभी रैशनल होराइजन पे है?
Okay, beta. Now for the sun, for now, just I will tell you that this is the instant we take the amplitude, and I'll explain it later in detail regarding the sun. For the sun, the amplitude is taken.
My question was just
when
at which instant we are taking the sun's amplitude.
I will tell you, I'll tell you. When you see the lower limb of the sun is 1 semi-diameter above your visible horizon. That is the time when we take the amplitude.
1 semi-diameter, sorry, above the horizon, right?
The lower limb of the sun is 1 semi-diameter above the visible horizon.
Okay,
Okay,
sir.
beta, got it?
I got my answer. Yes.
Okay. Let me explain the moon now. Now, just to make it a little more clear in your mind about the amplitude of moon not being practical, you can see this is a calculation picked up from the Principles of Navigation book from the altitudes chapter. You can see that the observed altitude of the moon's lower limb on a particular day was 0 degrees. This basically signifies the moonrise. Now, if you apply all these corrections, the dip correction, then the refraction correction, then the semi-diameter, and then the parallax correction. You will see that the true altitude of moon is already 28 minutes. So moon had already achieved a positive altitude. By the time you are able to see it, it appears on your horizon. You are already having the moon at 28 minutes of altitude. So that's why amplitude is not possible. Amplitude is taken at the instant when the true altitude of the body is 0 degrees 0 minutes. That means the center of the body is on the horizon. You can easily understand it from this particular diagram also. You can see the Earth on the left hand side, the big circle representing the Earth. We have an observer on top of the Earth, and it is having a certain height of I. So it is represented by this vertical line right now where the laser pointer is. Now from the eye of the observer, if you draw a tangent to the surface of Earth, this gives you your visible horizon. This is the visible horizon. From the eye of the observer, if you draw a tangent to the surface of Earth, this gives you the visible horizon. And the rational horizon, if you consider in this diagram, the rational horizon passes from the center of the Earth. So this horizontal line which you see, passing from the center of the Earth, every point on which is 90 degrees away from the zenith of the observer is the rational horizon. So you can see it is labeled as rational horizon, and the slanting line is labeled as visible horizon. Now we have compared the sun and the moon in this particular scenario, and moon is much closer to the Earth as compared to the sun. And you can see when the moon is rising in the morning, coming up from the eastern horizon, you see that it will first cross the rational horizon. After crossing the rational horizon, later on, it will reach to our visible horizon. So by the time we are able to see the moon, it has already attained a positive altitude. So telling us that the amplitude in this case will not be possible. Amplitude should be taken when the center of the body is on the rational horizon. Now let's compare it with the case of the sun. You can see the sun is much farther away from us as compared to the moon. So we have the sun much farther away, and you can see at this particular condition, the sun has already crossed the visible horizon. That means the sunrise has already occurred, and it will come to the rational horizon a little later. Now this is exactly the reason that when we take the amplitude of the sun, the amplitude is taken at that instant when the lower limb of the sun is 1 semi-diameter above the visible horizon. So when the lower limb of the sun is 1 semi-diameter above the visible horizon, that is the time when the center exactly lies on the rational horizon and the amplitude can be taken. This question beta also comes in our paper in the theory part in part C. So if the question comes, you can make this diagram. The question asks you to make a diagram explaining this. So you can make this particular diagram and explain. That answers the question. So any doubts?
Due to the distance.
When the sun is one lower limb of the rational horizon, correct sir?
Visible horizon बेटा, rational horizon हमें नहीं दिखती है, visible horizon.
Visible horizon, sorry, visible horizon से एक 1 semi diameter ऊपर होगा जब, तब हमें देखना है, correct sir?
That's right बेटा. Great बेटा, clear. So चलें, आगे चलें. Okay, beta. Very good. So the basics are more or less complete now. So I'm just closing out the slide. Okay, so the basics are more or less refreshed in our mind. And now we are ready to jump into the side solving methods. So as I told you, we have 5 side solving methods: Marpas, long bicron, intercept, X meridian and Polaris. इन पांचों मेथड्स को हम वन बाय वन देखने वाले हैं. गो अहेड जी.
सर बस एक चीज बता दीजिएगा, ये एक चीज कंफ्यूजन था सर, जब एल्टीट्यूड 000 डिग्री है, दैट इज जब एग्जैक्टली विजिबल होराइजन पे है, तब हम एम्पलीट्यूड रहते हैं, करेक्ट?
नो, जब आपका ट्रू ऑल्टीट्यूड 0 डिग्री 0 मिनट होता है, ट्रू ऑल्टीट्यूड, तब हम एम्पलीट्यूड लेते हैं. और ट्रू ऑल्टीट्यूड 0 डिग्री 0 मिनट होने का मतलब है सेंटर ऑफ द बॉडी शुड बी ऑन द रैशनल होराइजन.
ओके सर, गॉट इट, थैंक यू.
ओके ओके, सो वी आर गोइंग टू सी ऑल दीज 5 मेथड्स बेटा वन बाय वन. मैं आपको डिटेल में बताऊंगा कि इन मेथड से हमने क्वेश्चन को कैसे सॉल्व करना है. वी विल सी इट, व्हाट ऑल इंफॉर्मेशन इज गिवन, व्हाट इज द सीक्वेंस व्हिच वी फॉलो टू गेट टू द आंसर, क्या क्या चीजें हमें अपने सोल्यूशन में शो करनी है, and how we have to make the diagram. So starting off with the first method now, that is latitude by meridian altitude. When we are doing these methods, ये methods तो आप pre-C और second mid में भी कर चुके हो, so it will be a refresher. इनके साथ छोटे छोटे concept और add on होते जाएंगे बेटा. जैसे to give you an example, the concept of back angle. Sometimes, rarely, but sometimes a question comes in our paper जिसमें हमें back angle दिया हो सकता है. So we will see that. Then we will see comparison between long bicron and intercept method. उस पे भी कभी कभी question आता है. So ये concept हम साथ में pick up करते चले जाएंगे. So let me set up the side solving presentation now. Give me a minute. So starting with our first method, latitude by meridian altitude. Now, as is clear from the name, This method gives us the latitude of the observer, and this method is used when you take the altitude of a body on your meridian. The meridian altitude is also known as meridian passage or marpas. We are aware that all the celestial bodies, they rise on the eastern horizon. Then after rising, the altitude of the body keeps on increasing, and eventually it comes on the observer's horizon at its highest altitude of the day. After crossing the observer's meridian, the altitude starts to decrease. The body crosses over to the western side of the observer. The altitude starts to decrease and it eventually sets down on the western horizon. So during one complete day, one particular body will be crossing the altitude at one instant. Say if you take the example of the sun rises in the morning, then around noon time the sun has attained its highest altitude when it is on the meridian of the observer, when the meridian passage or marpas occurs, and after that the altitude of the sun decreases, and in the evening eventually the sun sets and goes below our horizon. So marpas method is used when the body is crossing the observer's meridian. Now let us see what all information is provided to us in these questions. The information provided is, number one, the date of the observation, the sextant meridian altitude of the body. They will give us the sextant altitude and they will give us an indication that it was the meridian passage. So sextant altitude at the time of marpas is known as sextant meridian altitude. Then to correct this sextant altitude, they will provide us the index error of the sextant and the height of eye of the observer. This is required for the dip correction. Along with this, they will provide us with the DR position of the ship. We will have the DR latitude and the DR longitude given to us in the question. Now in these questions, important thing to note is that most of the time the exact time of observation is not mentioned. In all the other observations which we are going to see, long bicron, intercept, X meridian, Polaris, you will always have the time of observation mentioned to you, exact time of observation, hour, minute and seconds. But in case of meridian altitude or marpas observation, the time is usually not provided to us. So how do we obtain this time? We obtain this time from the almanac itself. From the almanac, we first obtain the LMT of meridian passage of the body. So we have seen in the almanac the LMT meridian passage for the sun is provided to us. Coming to the second body, the moon, again the LMT meridian passage of the moon is provided to us in the almanac. Then for planets, again the LMT meridian passage of planets is also provided. It is given at the bottom of the page. For sun and moon, it is given at the bottom of the right side page, the daily page, the date page. And for the planets, it is given at the bottom of the left side page on the right corner. So bottom right corner of the left side page, you will have the LMT meridian passage of all the 4 planets. So we pick up this LMT marpas from the almanac and we apply the longitude in time. The DR position is given to us. We have the longitude divided by 15. We get the LIT. We apply the longitude in time and we get the GMT marpas of the observation. So we get the GMT time when the observation is taken. Now one doubt may arise at this instant, what is to be done in case of stars? The meridian passage of stars is not given to us. Now, fortunately, in the case of stars, the Marpas time is not required at all. Why is it not required for stars? This is because the declination of the stars does not change on a daily basis. It remains constant. So we need this time to calculate the declination of the body. So in case of stars, the declination does not change. It remains the same throughout the day. So the declination can be picked up straight away without bothering about the time of observation. For all the other bodies, sun, moon, as well as the planets, the declination keeps on changing hour to hour, minute to minute. So we require the time of observation for sun, moon, as well as the planets. Now, once the GMT Marpas is available to us, we can now pick up the declination. The hourly declination is picked up from the date page. Along with it, we also pick up the decorrection value. And we check this decorrection value increment from the increment table. And once we apply the increment, we are able to get the accurate declination of the body. So this is the first step. We obtain the declination of the body. Now in the second step, we correct the altitude of the body. We have the sextant altitude, we have the index error. So we have the height of eye with which we obtain the dip correction. Once we apply these two corrections, we get the apparent altitude of the body. Once apparent altitude is there, we apply the total correction and it gives us the true altitude of the body. Now, the true altitude of the body is named same as azimuth. Fundamentally speaking, the altitude does not have any name. No name is given to the altitude of the body. Now, if the altitude does not have any name, what is the purpose of naming the altitude here? The naming of altitude is done here just as a shortcut method to find out how the true altitude is to be combined with the declination of the body. So as I proceed further, I will tell you the true altitude has to be combined with the declination of the body. So how it is to be combined, whether the figures are to be added or subtracted. So this is just a shortcut method which we are using to find out whether we use a plus sign in the combination or a minus sign in the combination. If we don't use this shortcut method, in that case, we would need to make a rational horizon diagram, which will be time taking and it will make the question lengthier. However, when you are solving these questions for position lines, it is not mandatory to draw a rational horizon diagram. So just to save a bit of time, we use this shortcut method. As we proceed further, it will keep on getting clear to you. Now, once we obtain the true altitude, 90 minus true altitude gives us the MZD. MZD is meridional zenith distance of the body. What is the zenith distance of the body at the time of Marpas? That is what MZD is. So 90 minus true altitude gives us the MZD of the body. Now the MZD is named opposite to true altitude. Again, I'm repeating here, fundamentally MZD, meridional zenith distance, does not have any name. This is just a shortcut method which we are using to save some time in this question. Now, once we obtain the MZD, we already have the declination of the body known to us. So what we do now is we combine the MZD and declination. By combining, I mean either we will add the MZD to the declination, or we are going to subtract one value from the other. Now, how to decide whether they are to be added up or one of them is to be subtracted from the other? This is decided using these names which we gave. You see, we have given the name to the true altitude, same as azimuth. We have given the name to the MZD opposite to the true altitude. So we will now have a name for this MZD, which will be either north or south. Declination obviously has a name. It will be either north or south. Now we compare the names of MZD and declination. If both of them are having the same names, they are added up. And if they are having opposite names, then we subtract the smaller one from the bigger value and we retain the name of the bigger one. So I repeat, if MZD and declination are of the opposite name, we subtract the smaller value from the bigger one and we retain the name of the bigger one. Now once you do that, you obtain the observed latitude, a combination of MZD and declination gives us the observed latitude for this particular site. This observed latitude is our position line. In this particular case, the Marpas observation, the latitude what we obtain by combining the MZD and the declination is the position line itself. Now whenever we find the position line, we always denote the direction in which the position line lies. So in this particular case, the direction of the position line is east-west. The PL runs in the east-west direction because this observed latitude is our PL. All the latitudes, parallels of latitude, they run in the east-west direction. So hence the position line which we obtained here is lying in the east-west direction. Now a doubt could arise in your mind that we have named the true altitude of the body same as azimuth. Now how to obtain the azimuth of the body? How can we find out what is the azimuth of the body? Now practically on board a ship, this will not be a problem at all, because when you take the sight of the sun, you take the bearing of the sun, you will be able to easily identify whether it is north of you or it is south of you. When you take the bearing of the sun at the time of Marpas, you will be able to easily identify whether it is north of you or south of you. At the time of meridian passage, the body will either be exactly north of you or it will be exactly south of you. It cannot be in any other direction because the body is on your meridian and the meridian runs in the north-south direction. However, theoretically, when you are solving these questions in the exam, how can we easily find out what is the azimuth of the body? Is it north or is it south? So let me explain that to you in the coming slide. I will tell you with a small simple rough diagram. We can easily identify and find out what is the name of the azimuth or in which direction does the body lie. So again, I'm emphasizing that naming the true altitude and naming the MZD is not fundamental. It is not fundamentally done. True altitude and MZD are not given any names. We have just named them to save some time in the question, because by naming them, we were able to find out whether MZD and declination are to be added or one of them is to be subtracted from the other. So in case we don't use this method, then we need to make the rational horizon diagram, which will take some time. So just for the purpose of saving this time, we have used a shortcut method. So beta, you have the complete method in front of you right from beginning to end. So before I proceed to the next slide, any doubt in the method, beta?
No, sir.
Very good, beta. Great. So let's move. Let me now show you the azimuth calculation. Go ahead, beta.
Can you again just say a statement we said initially, that why we are finding out this observer altitude? What is the purpose? What is the purpose of this latitude by meridian altitude?
The purpose of this method. The purpose is basically to get a PL, and the PL is the observed latitude itself. The latitude which we have obtained is the PL. It is also our fixed latitude. So the method gives us a PL beta position line.
So this PL we are finding out to get the position of what, sir? That body
Okay. I'll tell you, beta. Beta, all these 5 methods which we are doing, these methods basically give us position lines. And why do we need position lines? We need position lines to fix the vessel's position, to fix the ship's position. So for fixing up the position, we need minimum 2 PLs.
Yes, sir.
Right? So all these methods will give us one PL. And if we have 2 bodies, we will combine one method using 1 body, then another body, 2 PLs, and they are going to give us the fix. This is the full procedure.
Okay. Okay, sir. Got it.
Okay, beta. Great. Let's move ahead. Now, let me explain to you a easy method how to determine the azimuth of the body theoretically. Now, just draw a simple rough diagram showing the meridian of the observer. So you draw a vertical line which represents the meridian of the observer, and in the middle you show the equator. So you see this horizontal line, it represents the equator. So let's label it as equator here. So vertical line representing the meridian of the observer, the horizontal line representing the equator. Now in this diagram, we are going to fit the celestial body and the observer. How are we going to fit them here? The celestial body is put in this diagram basis its declination. Now let's assume the declination of the celestial body was 20 degrees south. Just assuming a figure for understanding. So what we do is from the equator, we go 20 degrees down south and we show the body here. You can see the star shown here in this particular location in the diagram. Now, once the celestial body is there in the diagram, we now fit the observer. The observer is put in this diagram basis the latitude of the observer. So whatever is the latitude basis that you put the observer in this diagram. The DR latitude is available to us in the question. So let's assume that the latitude is given as 30 degrees north. So from the equator, we go approximately 30 degrees north and we fit the observer here. This is just a rough diagram, not to scale, just to understand in which direction the body will be when it is crossing our meridian. So observer is put in this diagram basis his latitude. The body is put in this diagram basis its declination. And you can see clearly now that when the body is on the observer's meridian, it is passing south of the observer. So the azimuth of the body is south at the time of meridian passage. So this is what we use in our shortcut method. The true altitude is named same as azimuth. So in this particular case, the true altitude would be named south and the MZD is named opposite to it. So MZD in this particular case will be named north. And once we know what is the name of the declination, we will immediately come to know whether MZD and declination are to be added up or one of them is to be subtracted from the other. So this is a very simple rough diagram. You can make it in the rough column and find out what will be the azimuth of the body at the time of Marpas.
Sir, in this question, in this example, you have shown the declination of the star is south and the DR lat is north, right?
Right, beta.
Okay, okay.
Sir, in this example, you have just taken this declination as latitude, right? Actually, it is the reference from latitude only, same as, but in the celestial sphere, right? So in this you have in this you have just for the sake of knowing that where the body is, you have put it in this equator, near the equator, right?
Exactly, beta. That's right.
Okay, sir. Okay, got it.
So what if the same it was 30 degrees south then?
You mean to say latitude and declination are the same?
No, sir. Let's keep the declination as 20 degrees south. And what if the observer is now becoming 30 degrees south then?
Okay. Now, if the observer is 30 degrees south, okay, let me put the...
Azimuth would be north in that case, right?
North of observer, na, then it will be north.
You mean to say observer is 30 degrees south. So observer would come here and the body will be north of the observer. Can you see, beta, I have shifted the observer's position?
Yes, I saw the man going down.
Yeah, so the body will be north of the observer in this case.
And if both are together, then what would be the true altitude?
You mean to say both are having the same declination, same lat?
Yes.
Okay, if the declination and latitude are the same, then the body will be crossing exactly overhead of the observer. That means it will be crossing the zenith of the observer and its meridian altitude that time would be exactly 90 degrees. You will not be able to take it.
Correct. And that is exactly what the almanac gives us as the Marpas time, right?
Yeah, right, beta.
Okay, thank you.
Okay, beta. Great. So I hope the method is clear. If you are clear about this, then we can proceed to the next method.
Yes, almanac is giving us the time when the body is going just above us, meridian passage.
Beta, almanac gives you the time of meridian passage. It does not say that the body will be exactly overhead of you. That will be happening only if the latitude and declination are same.
Okay, sir, got it, got it.
Okay.
Sir, this method we will be using for every celestial body, sir. Yes, sun, star, planet, moon.
Every celestial body, beta. Same method, sun, star, planet, and moon. It will apply to all the bodies. You can apply it and it will give you the answer.
Okay, sir.
Great. So, चलें बेटा, आगे चलें?
Yes, yes, sir.
Very good. Now, बेटा, when you are doing these questions with the moon, तो एक छोटा सा concept और आता है moon के case में, and that is the concept of longitude correction. So, let me explain to you what is this longitude correction. So, let's see the longitude correction part. Let us now understand the concept of longitude correction. Now we are aware that the times of rising, setting, and meridian passage of the moon are listed in the nautical almanac. These times which are listed, the rising time, setting time, and the meridian passage times, are the times of these occurrences on the Greenwich meridian. If you are on any other meridian other than Greenwich, this time has to be corrected for the longitude of the observer, and this is called as longitude correction. Since this correction is based on the longitude of the observer, the name given to it is longitude correction. Now the doubt which arises in our mind is, why are we applying this extra correction for the moon? We did not apply any longitude correction in the case of sun. Now the reason for that is, this correction is required because these moon phenomena, that is the rising, the setting, or the meridian passage of the moon, they occur about 51 minutes late every day. There is a delay in these occurrences day after day. Every day the moon gets late by about 51 minutes. Now let me pick up the data from the daily page of the almanac and show you this delay. You can see the data picked up for the moon for a particular day. And if you have a look at the meridian passage time of the moon, we will have a look at the upper meridian passage. On the first day, the upper meridian passage is happening at 0500 hours. If you have a look at the second day, the meridian passage of the moon occurs at 0552 hours. So you can see there is a delay of 52 minutes. This delay is not fixed or constant. It keeps on varying day after day. There can be a slight change in the value, and the average delay which is there is about 51 minutes. On the third day, you can see the meridian passage of the moon gets delayed again, and the upper Marpas time is 0644 hours. Now, in the case of the sun, these phenomena, they occur almost at the same time on the next day. Let me now show you the figures for the sun also on the same day. You can now have a look at the sun's information. You can see on 24th day, the meridian passage of the sun occurred at 1213. On the next day, that is on 25th, again the meridian passage occurred at 1213, and on 26th, the meridian passage of the sun occurred at 1213 hours. So you can see now the in case of the sun, the phenomena occurs almost at the same time on the next day. Maximum difference which can be there in case of the sun is 1 minute, whereas in the case of moon, there is a delay of about 51 minutes day after day.
Why the
Now
moon
on
has
24th, the meridian passage of the sun has occurred at 1213 local time on Greenwich. After this meridian passage, the sun has moved around by 360 degrees in a day, covering all the other meridians, and again on next day, that is on 25th, the meridian passage of the sun has occurred on the Greenwich meridian at 1213 local time. Now at all the intermediate meridians, the meridian passage would occur at the same time, that is 1213 hours. There is no difference between 24th Marpas and 25th Marpas local time at the Greenwich meridian. So all the other meridian, the observer can be on any other meridian. The Marpas of the sun would occur at 1213 local time only. Now if you have a look in the case of moon, on the first day, the upper meridian passage of the moon occurred at 0500 local time at Greenwich. After this, the moon, once it passes the Greenwich meridian, it passes over all the other meridians, and once it covers 360 degrees, the moon again comes back to the Greenwich meridian, and the next day Marpas occurs at 0552 local time at Greenwich. Now we can see there is a delay of 52 minutes in this case. Now this delay has occurred gradually over the entire 360 degrees. Hence, if you are on any other meridian other than Greenwich, while calculating the LMT of these phenomena, this daily difference, in our case the daily difference is 52 minutes, this has to be interpolated for the longitude of the observer, and it has to be applied to the Marpas time given for Greenwich meridian in the almanac. Now if you go a little deeper and try to understand why this delay is there in the case of moon. The delay happens because in the case of sun, the rate at which the sun travels is 15 degrees per hour. And the rate at which the local time changes is also 15 degrees per hour. So as the sun keeps on traveling at the same rate, the local time also keeps on changing, and the Marpas of the sun occurs at the same time at all the meridians. Now in the case of moon, the moon travels at a rate of about 14 degree 19 minutes. It keeps on increasing and decreasing slightly from this amount, increasing from this amount. So the average speed of the moon is less than 15 degrees, but the rate at which the time changes, the local time changes, is 15 degrees per hour. That leads to the moon getting delayed for the next meridian passage. So beta, before I tell you to how to apply these corrections, how to apply this longitude correction, you can go through these points. Any doubt coming in, let me know.
So why there is no upper and lower in for Marpas in sun?
As per local time changes, so you said in case of sun, local time changes is 15 degrees per hour, correct? So in case of moon also it is 15 degrees per hour, right?
The change of local time is at the rate of 15 degrees per hour, beta. It does not depend upon the body.
So, correct. Correct. So when you subtract 14 degrees 19 from 15 for 1 hour, if you multiply that by 24, it comes somewhere about 51 minutes only, sir.
That's right, beta. You are right. Okay, beta. If you are comfortable up to here, shall I tell you how to apply this longitude correction now?
Yes, sir, please.
Very good. Let's go.
So this type of question also asked in the theory part.
No बेटा, this does not come in theory. ये मैंने सिर्फ आपकी अंडरस्टैंडिंग के लिए बताया है. ये रेयरली आता है, बट इट कैन कम. आपके क्वेश्चन नंबर 5 और 6 में अगर मून का क्वेश्चन ये डाल दें और ये मरपास का क्वेश्चन हो तो उसमें आपको ये लॉन्जिट्यूड करेक्शन लगाना पड़ सकता है. सो आई कुड हैव लेफ्ट इट ऑल्सो, बट इट इज बेटर दैट यू आर रेडी. इफ इट कम्स इन द एग्जाम यू शुड बी एबल टू सॉल्व इट.
Okay.
Okay, beta. Let us now see what is more important, how to apply this correction. Now, having understood the concept behind the longitude correction, let us see how do we apply this longitude correction. So for longitude correction, first we note down the LMT of the phenomena, moonrise or moonset or meridian passage, for the date which is given in the question. We compare this time with the LMT of earlier occurrence if the longitude is east. Earlier occurrence means the time of the phenomena on the previous day. So if the longitude of the observer is easterly longitude, we compare it with the LMT of earlier occurrence. And If the longitude is west, observer's longitude is west, we compare this time with the LMT of the next occurrence. Next occurrence means the time of the phenomena on the next day. So remember, repeating once again, if the longitude is east, compare it with the earlier occurrence time, that is the time given for the previous day. And if the longitude is west, compare this with the LMT of the next occurrence or the time given for the next day. Find out the difference between these two times. The difference between these two occurrences is called or known as the daily difference. This is the delay which has happened in the case of moon over the phenomena for the next day. Now, once we have obtained the daily difference, we can use this daily difference to obtain the longitude correction. The formula which we use is longitude correction is equal to the daily difference multiplied by the longitude of the observer whole divided by 360 degrees. If you look closely, this formula is nothing but the interpolation. The daily difference is happening over entire 360 degrees. We are interpolating it for the longitude of the observer and finding out what will be the delay when the moon reaches at the observer's meridian. Now, once you have obtained this longitude correction, this correction is applied to the LMT of the phenomena. It could be moonrise, it could be moonset, or it could be the meridian passage of the moon for the date in question. This is the same value which we had taken in the first step. So you pick up the time for the date given in the question, apply this longitude correction to that time. Now, what do we mean by apply? This longitude correction could be positive plus, or it could be negative minus. How do we decide whether this longitude correction is plus or it is to be added, or it is negative and is to be subtracted? So for this, again, we look at the longitude of the observer. If the longitude is east, the correction is subtracted from the time given in the almanac for the date in question. And if the longitude is west, the correction is added. So repeating once again, if longitude is east, the correction is subtracted, and if longitude is west, the correction is added. Once the correction is applied, you get the accurate time of the phenomena for the observer's meridian on the date given in the question.
So can you discuss one example?
The longitude will write in the degree units, correct?
Okay, just a minute, beta. I'll give you the example in the assignment, beta. I'll give you a question on this, so you can do it. You can see the solution also.
Sir, the longitude will be in degree or minute or a minute only?
Beta, you can round off the longitude to degrees and decimal of a degree, or you can write it in degree minutes, whichever format. Both will be correct.
Okay, sir.
Okay, so as I told you, beta, this comes rarely. This is not a regular question in our paper, but in case it comes, you now know how this is to be applied. Okay, so if you are comfortable, chale beta, आगे चलें?
Yes, sir.
Very good.
Yes, sir.
Great. Just give me 1 minute. The next which we have is the long by chron method now. So we are moving into the longitude by chronometer method. Let's move on to our second method of obtaining position lines, that is longitude by chronometer. Now, in our first method, which was latitude by meridian altitude or MARPAS, we have seen that by obtaining the altitude of a body at the time of meridian passage, we are able to obtain a position line which matches with the latitude of the observer, and we call it observed lat. Now, the meridian passage method is very quick, easy, and convenient to do. But there is one restriction which the meridian passage method has. And that restriction is that any particular celestial body will come on our meridian or cross the meridian or pass the meridian at only one particular time in a day. Taking the example of the sun, you see sun rises on the eastern horizon in the morning. Then it crosses the meridian around noon time, meridian passage time. It crosses over to the western side of the observer, and then eventually at the evening time it sets on the western horizon. So you see during the entire day the sun crosses the observer's meridian only at one particular time, and we can use the meridian passage method only at that instant. Now, if we want to use the body to obtain a position line before meridian passage or after meridian passage, we need to have some other method. MARPAS cannot be used there. So this is exactly where the next two methods come in. First method is the longitude by chronometer method, and the second method is the intercept method. So these are the ones which we are going to discuss now one by one. Now, first of all, coming to longitude by chronometer. As is clear from the name, this method tells us that we can obtain the longitude of the observer if we have the chronometer. Chronometer basically means GMT. So the name of the method tells us that if we know the GMT and we observe a particular body, or we take the site of a particular celestial body, we will be able to obtain a longitude. So that is the essence or the meaning of the method, longitude by chronometer. Now, one important thing to remember here before we proceed into the method, that the longitude which we obtain is not the fixed longitude of the observer. So obviously a doubt will arise in your mind, then what longitude it is. I will explain it to you once we reach up to the diagram of this particular method. The longitude is where the PL cuts the DR latitude. So it will be clear to you once we complete the procedure and we draw the diagram that this longitude is not the fixed longitude. So anyway, first of all, let's see what all information is provided to us in these type of questions, and what is the method, what is the formula which we use to obtain the position line. Now, first of all, let's go into the information which is provided. The info provided in these questions is the date and time of observation, the time may be given as GMT straight away, or they may give us the chronometer time. Obviously, if the time is given as chronometer time, it will have the chronometer ambiguity, and we will need to resolve the chronometer ambiguity. So for the chronometer ambiguity, a AM or PM indication is given to us in the question. Now the second information which is provided to us is the sextant altitude of the body. Along with the sextant altitude, they give us the index error and the height of I. Both of these are required for altitude correction. And the third thing which is provided in these questions is the DR position, the DR latitude and the DR longitude. So this is exactly all the information which is available to the navigator when he takes a site. He will be able to find the exact date and time when the site is taken. He will be able to get the sextant altitude of the body. He will know what is the index error of the sextant. He will know what is my height of eye in this particular condition of loading. And he will also know what is the TR position of the ship. So this is the information which is given to us in the question. Now, how do we proceed ahead? Now, the first thing which we do is, if it is chronometer time, we resolve the chronometer ambiguity and we get the exact GMT date, hour, minute, and second. Once the exact GMT is available to us, we enter into the almanac, and for that particular body, we get the GHA of the body. We get the almanac information out. So when you look for GHA on the daily page, you will be able to find out the hourly GHA, and from the increment table, you will be able to find out what is the increment for the particular minute and second of the time which is given to us in the question. And if the body requires a V correction, the planets and the moon, they both need the V correction also. So we can get the value of hourly V correction from the daily page, and we can get the increment from the increment table under that particular minute for which the GMT is given. So the V correction increment is also picked up if required for that particular celestial body. And once you combine all three of them, increment is always added, whereas V correction could be plus or it could be minus. It is negative only for one planet, that is Venus. It could be negative, it could be positive. However, in most of the pages in the 1992 almanac, selected pages which we have, the V correction for Venus is in negative. For all other bodies, the planets Mars, Jupiter, and Saturn, as well as the moon, the V correction is always positive. So increment is always added and V correction is applied as per the sign. And once you do that, you will get the accurate GHA of the body. So this is the first step. We obtain the accurate GHA of the body. Now, once we have the GHA with us, we also have the DR longitude known. DR longitude is given to us in the information. So when we apply this DR longitude to the GHA, we get the LHA of the body. So we find out the LHA of the body. Now with this LHA, we write the word approximate. So you can put a bracket and write along with that LHA as approx or approximate. Now why are we indicating as approximate? The reason for that is that we have used the DR longitude to obtain the LHA. Now DR longitude could have errors in it. So that's why the value of LHA will not be accurate. The GHA was exactly accurate for that particular date, hour, minute, and second. However, there could be an error in the DR longitude, giving an error in the LHA also. That's why we have written approximate here. The second reason is later on in the question, we will be finding the exact LHA also. And just to distinguish between the two, we have marked it as approximate. Beta, any doubts? Go ahead.
Yes, sir. Sir, the V correction you said only for planets and stars, right?
For planets and moon, beta. V correction is there for planets and moon. No V correction is there for sun and stars.
This GHA and DR longitude is added or subtracted, sir?
Beta longitude east, GHA least, longitude west, GHA best. Use this idiom.
Yes, sir.
Okay. Any more doubts up to here, beta? Very
No,
good.
sir.
Great. Let's move ahead then.
Sir, if this DR longitude is not given in the question, only the latitude is given, then
It will always be given, beta. Longitude will be given to you.
okay, sir.
Okay. Now, once LHA is known, then we go into the almanac again. The second information regarding the body which is given in the almanac is the declination. Now from the daily page, from the date page, we will be able to get the hourly declination for the particular GMTR. We will also get the value of D correction from the daily page itself. And when we go into the increment table, we can find out the increment for the D correction for that particular minute which is given in the GMT. Once applied, it gives you the accurate declination of the body. So we have obtained the GHA, approximate LHA, and the declination of the body. That is step 1. Now moving on to the next step. The next information you see we have is the sextant altitude. We will correct this altitude now. We will first apply the index error. If it is on, you put it off. If it is off, you put it on. Then we apply the height of I using the dip correction. The dip correction is always negative, obtained from the table given on first page of the almanac. And once these two corrections are applied, we obtain the apparent altitude of the body. With the apparent altitude, we can now enter into the almanac and obtain the total correction for the body. We are familiar with the total correction table of sun, stars and planet as well as moon. So we apply the total correction to the apparent altitude, and once applied, it gives us the true altitude of the body. So this is number 2. So we obtain the true altitude of the body. Now once we obtain the true altitude, GHA and the declination, we are now ready to apply the Long-Bicron formula. What is the Long-Bicron formula? The Long-Bicron formula says cos of P. This is the same P which we saw in azimuth calculation in the ABC method. So P is basically angle P of the PZX triangle, and it is derived from the LHA of the body. It could be equal to LHA or it could be equal to EHA or 360 minus LHA. So cos of P is equal to sine of true altitude minus plus sine of latitude multiplied by sine of declination whole divided by cos of latitude multiplied by cos of declination. Now a couple of things in this formula. P, as I already told you, is obtained or is the same as we used in the ABC method. P is either equal to LHA or P is equal to 360 minus LHA. In this case, we are going to calculate the value of P here in this formula. The true altitude, first term is sine of true altitude. The true altitude is already known. We have corrected the sextant altitude and obtained it. Then we see a minus plus sign. Now, what does this minus plus indicates? It indicates that in this formula, we will either use a minus here or a plus here. Now, which one of the two symbols is to be used? The upper symbol in these kind of equations, upper symbol is always used when the following terms, that is latitude and declination, are of the same names, and the lower symbol is used when the following terms, that is latitude and declination, are of the opposite names. So in this particular case, when latitude and declination are of the same name, we will be having the upper sign, which is a minus in this case. And when latitude and declination are of the opposite names, we will have a lower sign, and that is plus. The latitude used in the formula is the dr latitude. Dr latitude is available to us as dr position is known. Then we have declination. Declination has been calculated from the almanac information. We have the accurate declination with us. In the denominator, again, we have the latitude, for which we use the dr lat, and the declination, which is known to us. So you can see in this formula, all the terms which are there on the right hand side are known to us. So with all these terms known, we put them into the formula, and with a single step calculation in the scientific calculator, we will be able to obtain the value of P. So we calculate the value of P using this formula. Now this is a very important formula. It is to be memorized by heart. So please memorize this formula. The only way this question can go wrong is if you apply the formula wrongly. Otherwise, the question is pretty straightforward, straight and simple. Now, once you obtain the value of P from this formula, from this value of P, now we can obtain the exact or accurate LHA. See, we calculated the LHA using the dr longitude also, but that was approximate. Using this value of P, we can now calculate the exact or accurate LHA. Now, when we find out LHA from P, one doubt which is going to arise in our mind is whether P is equal to LHA or P is equal to 360 minus LHA. Now this doubt does not arise when we find the value of P from LHA, because we know when LHA is less than 180, P is equal to LHA. When LHA is more than 180, P is equal to 360 minus LHA. But in this case, the value of LHA is not known to us in the first place. So we don't know whether P will be equal to LHA or P will be equal to 360 minus LHA. So how to determine? Now this is where the approximate LHA comes to our use. Now you have a look at the approx LHA. If the value of P is close to this approx LHA, that tells you that P will be equal to LHA. And if the value of P does not match at all with the approx LHA, you do 360 minus P, and you will see whatever answer you get, it will match with your approx LHA value. Usually 90% of the questions, this will be within a degree. That means whatever LHA you have calculated, you will get one of these values, either P or 360 minus P, within a degree of the approx LHA. So it immediately gives you an indication whether P will be equal to LHA or P will be equal to 360 minus LHA. So repeating once again, whatever value of P is obtained, compare that value with the approx LHA. If both of them are matching or they are close to each other, you take P equal to LHA. And if both of them are not matching, you subtract P from 360, get 360 minus P, and you will see that that value is going to match up with the approx LHA. So this tells you that in this case, LHA will be equal to 360 minus P. So this is how we obtain the value of LHA from the value of P. So beta, I hope it is okay up to
So
here.
the 360, 360.
Go ahead, beta.
Sir, ये LHA approx will be given in the question.
LHA approx will not be given in the question. You will find it using the DR longitude and the GHA.
अगर DR long भी नहीं दिया हो तो?
बेटा DR long दिया होगा क्वेश्चंस में. अगर नहीं दिया होगा किसी क्वेश्चन में, there is a slight possibility. Then you bring the question. Okay, you bring the question here. We will see what other hint is given. I'll tell you that.
So just one more thing.
Right, beta. Right. In some other question, they may tell you body is east or west. So in that case, you don't need approx LHA. If body is west of you, you know LHA has to be less than 180. If it is east of you, you know LHA has to be greater than 180. Okay. बट अगर आपको ये नहीं भी समझ में आया तो अभी के लिए इसको छोड़ दो. अगर ऐसा क्वेश्चन आएगा, I'll explain it.
So one more thing, when we get the value of P, then we have to determine that it is before Marpas also, right? Because when you get GMT, there are two instances where you can get the value of local time. Then we have to determine that, right? If we have to get the morning time, then if you're getting morning time for that day, before the Marpas time, then the long bicron is passing before the meridian passage, right?
Why do you need to calculate that, beta?
So because I know, I just remember from second mid time, because we were giving chronometer time, right? So
Not required, beta. Not required. Don't worry. Not required at all. You follow this method. आपको कुछ और करना नहीं पड़ेगा.
Okay. No.
So can you repeat the last one? If the P is not matching with approx LHA, then 360 minus LHA, right? 360 minus approx LHA.
No, beta. 360 minus P.
Okay, sir. Okay. 360 minus.
You do 360 minus P, and that value will match with approx LHA.
Okay.
Okay. So चलें बेटा, आगे चलें.
Yes, sir.
Very good. So LHA हमारे पास आ गया है. We are now moving ahead. Now, once LHA is obtained, we have the accurate LHA now, which is calculated using the Long-Bicron formula. We can now compare this LHA with the GHA of the body. The GHA of the body has been already calculated earlier, found out from the almanac. So you compare this accurate LHA or the exact LHA with the GHA of the body. And when you compare both of them, their difference gives you the observed longitude. The difference between GHA of a body and the LHA of a body is determined by the longitude of the observer. So when you have both LHA and GHA known to you, you will be able to easily find out the longitude from their difference. Now this longitude which you obtain from the difference of GHA and LHA is called as observed longitude, because this longitude has been obtained by observing the body or by taking an observation of the body, which we call as sight. So we have obtained the observed longitude here. This was the name of the method, longitude by chronometer. Now, as far as the position line is concerned, only finding the observed longitude is not sufficient. We also need to find out the direction of the position line. We have a reference point now from where the position line passes, that is the observed longitude, but we also need to know what is the direction in which the PL lies. So for that, we need to calculate the azimuth of the body. In case of celestial bodies, the position line of the body, position line obtained from the body, always lies perpendicular to the azimuth of the body. So always remember, in case of celestial observation, the azimuth of the body is always perpendicular to the position line. So if you want to find out the direction in which the position line lies, find the azimuth of the body and perpendicular to it, 90 degrees away from it, is where the PL will pass or lie. How do we get the azimuth of the body? Now for the azimuth we use the ABC method. We are aware in the ABC method A is equal to tangent latitude upon tangent P, named opposite to latitude if P is less than 90, and named same as latitude, that is unusual cases, very few cases, it is named same as latitude in case P is greater than 90. So after A, we obtain the value of B. B is equal to tangent declination upon sine of P. Declination is known to us. The value of P is also known to us. We have calculated P using the formula. Same way for A, the latitude used is the TR latitude, which is available in these questions, and the value of P is obtained from the formula. So B, once calculated, is named same as declination. And once we get A and B, combining A and B together gives us the value of C. By combining, I mean they could be added or subtracted. If they are both of the same name, both are added up and the name is retained. And if they are of opposite names, then the smaller value is subtracted from the bigger value and the name of the bigger one is retained for C. Once C is obtained, we put it into the formula of tan azimuth is equal to 1 by C into cos of latitude. So we have the value of C now obtained from A and B, and we have the latitude which is given to us in the question. So using these two, we obtain the azimuth of the body. This azimuth is in the quadrantal notation. We obtain the quadrant using the name of C and the value of LHA. So once the azimuth is obtained, we are aware now that a celestial position line is always perpendicular to the azimuth of the body. So adding and subtracting 90 degrees gives us the direction in which the position line lies. So we have obtained the direction in which the PL lies, and we have also obtained the observed longitude. These are the two items which are required in these questions. And when we have these two items known to us, we are able to plot this position line easily on the chart. You have a reference position which is given by observed longitude. And what about the latitude? The latitude used is the DR latitude only. DR latitude and the observed longitude gives us the reference position from where the PL passes, and the azimuth gives us the direction of the PL because we know that PL is always perpendicular to the azimuth of the body. So beta, we have the complete method in front of us now, right from beginning to end. So any doubt coming in any of the steps, please share with me.
So in MMD, are they asking direct questions like this in second?
Yes, beta. Sometimes direct question comes. If somebody wants to put a simple paper, they will give you the direct question also.
Wow. Okay.
Okay. Otherwise, there is a little bit of twist. So once we are done with the simpler ones, then I will tell you where all the twists are.
Okay, sir. So just one small thing. I really forgot about the chronometer, sir. What was the error of that? वो fast and slow का कुछ तो था ना chronometer में.
Beta, it is good you forgot about it. It is out of syllabus now. It will not come.
अच्छा नहीं पूछते. Okay, good. Okay.
Yes, you can forget about the chronometer error.
So it means in questions there won't be any ambiguity, sir. So direct they will give GMT only.
There can be a 12-hour ambiguity, beta. 12-hour ambiguity can be there, but chronometer error will not be there.
Yes, sir, correct. Vaishak is asking the same thing which I wanted to ask, the 12-hour ambiguity.
Yeah, right. So चलें बेटा, आगे चलें?
Yes, sir.
Okay,
yes.
Let's go.
Yes.
So this is the complete method. How do we obtain a position line using the longitude by chronometer method? Now this formula for long
Sir,
by chron.
In the end, you said we need to find out which side the position line, azimuth lies. Which side of the DR position to draw the PL?
No, beta, not required. You just need the direction of the azimuth, and PL will be perpendicular to the azimuth.
Okay, sir, got it.
Okay, I'll show you. We'll make a diagram now. I'll show you. Okay, now before we go and make a diagram, there could be a bit of confusion in getting longitude from LHA and GHA. So let me explain that also. If any confusion is there, so that also will get sorted out. Now, some candidates may have a doubt in their mind how to compare the LHA and GHA to obtain the longitude in this question. I told you in this question that we get the value of P from the formula which gives us the LHA. We compare LHA and GHA and obtain the longitude. Now how to compare both of them? Should we do LHA minus GHA or GHA minus LHA, or what should we do? Or we add them, we subtract them. So let's see a very simple and easy procedure stepwise. Compare the LHA and GHA. Look at the values of LHA and GHA. You will find one of them will be smaller than the other. One will be greater, one will be smaller. So irrespective of which one is greater or which one is smaller, you subtract the smaller one from the bigger one. Or in other words, you find their difference. You have the GHA with you, you have the LHA with you, find the difference between them. In case GHA is best or greater, you give it the name as west. And if GHA is least or smaller, you give it the name as east. So you know we have that idiom, longitude west, GHA best, longitude east, GHA least. So we are using that same idiom here. If the GHA is best, name the longitude as west. And if the GHA is least, name the longitude as east. So once it is done, now the last thing, in case by following the previous two steps, you obtain the answer which is greater than 180. Now our longitude cannot be more than 180. We have two hemispheres, eastern and western hemisphere, both stretching up to 180 degrees. So in case you get a answer greater than 180, subtract it from 360 and change the name. We had done the naming in step number 2 here. So if the value is greater than 180, you subtract it from 360 and you also change the name. The value coming more than 180 basically tells you that it is in the other hemisphere. So you subtract it from 360 and change the name. So this is the simple procedure. Compare both of them, find the difference, subtract the smaller one from the bigger one. GHA best, longitude west, GHA least, longitude east. If the answer is greater than 180, subtract from 360 and change the name. You have the longitude known to you. So clear beta, चलें आगे?
Yes, sir. Sir, same like this LHA approx, we also have this DR long, no? So longitude approx we have also. So we can compare with this one also, coming nearby or no? No, the answer,
बेटा
sir.
आप कर नहीं पाओगे. You can try. There will be some confusion somewhere. So, but you follow this method, you will not have any problems.
Okay, sir.
Okay. Okay. All right. Let me show you the diagram also. Let's now see how do we draw the position line obtained with the longitude by chronometer method. We have basically obtained or calculated two things here. One is the observed longitude and second is the direction of the PL, which is perpendicular to the azimuth of the body. So how do we go ahead and plot this position line on the chart? We use the DR latitude. Let's plot the DR latitude in our diagram. You see the DR latitude plotted. Now we have also calculated the observed longitude. So let's plot the observed longitude also. You have this vertical line representing the observed longitude. Now this position, that is the DR latitude and the observed longitude, is the position from where the PL passes. Now once you have this, now you draw the azimuth of the body. We have obtained the azimuth also. Let us assume that the body was somewhere here. And if you plot the azimuth, it will be represented by this red arrow line. Now once the azimuth is plotted, we know perpendicular to the azimuth is the position line. So at right angles to the azimuth of the body, draw the PL. So this green color line which you see is the position line, and this is how it is plotted. It is also called as a LOP, that is line of position, or a PL, that is position line. So this is how we plot the position line on our chart or on our plot. So clear beta, this method is clear?
सर इस जो हमने डायग्राम बनाया है इसके अंदर हमें क्या डीआर लॉन्ग भी डिपिक्ट करना होता है या नहीं जरूरत है?
Not necessary beta, not necessary.
Okay. Because I remember back in the pre-C, our teacher used to emphasize on this thing कि ऐसे डालना है. Okay sir, ये नहीं जरूरत तो नहीं हटा दें.
Right beta, not necessary.
So just one thing I would like to share from my experience. So we had got I think 2 years back AMSA inspector. We had got AMSA inspection, and that time one surveyor came and he was checking the celestial plots and all. So that time, as I think Ashish was saying that to plot the DR log, and I just came on the watch at 12 o'clock, and he was asking me that this is all wrong. you have to plot the DR long also along with the obs long. Now, I don't know why you were saying that.
अरे जहाज पे सब अंडेबाजी करते हैं यार.
Okay, beta. If you feel that way and if you want, you can show it. There is no harm in it, beta. उसका कोई नुकसान तो नहीं है. 5 सेकंड और लगेंगे. But as far as the plot is concerned, see, we are interested in finding the position line. एक बार हमें observe long मिल गया, हमें पता चल गया PL कहाँ से पास होनी है, the job is done. So if you are comfortable plotting it, please do. No issues with that.
कुछ नहीं सर, उसको बस ये दिखाना रहेगा कि मुझे तुमसे ज्यादा आता है.
Right. Okay. So shall I close the presentation, beta?
Yes, sir.
Yes, sir.
Okay. Okay, beta. Okay. Let me see now.
Assignment नहीं है क्या आज?
एक मिनट बेटा, just give me a minute. ओके बेटा, अब मुझे एक बात बताओ. द टाइम नाउ इज 7:51. हमारा एक और छोटा सा टॉपिक है विच इज द टॉपिक ऑफ बैक एंगल. हम उसे आज भी कर सकते हैं, हम उसे नेक्स्ट लेक्चर में भी कर सकते हैं. सो एज यू से वी कैन डू दैट.
सर हमें आज कर कहते हैं सर, क्योंकि शुरुआत में टाइम ज्यादा खर्च हो जाता है कभी डाउट्स में ना सर. डाउट्स भी अनअवॉइडेबल हैं.
इट मे टेक अबाउट 20 मिनट्स और सो. उतना टाइम हमें लगेगा, राइट?
हाँ सर.
सर नेक्स्ट लेक्चर.
कभी डाउट्स में टाइम
बेटर नेक्स्ट टाइम.
नेक्स्ट लेक्चर में सर, नेक्स्ट लेक्चर
जो आपने पढ़ाया उसमें ट्राई कर लेंगे एटलीस्ट वो क्वेश्चंस.
ठीक है बेटा. I don't want a high level alarm and overflow, so let it be here. We will do it in the next lecture. Don't worry, we are comfortable.
वगैरह पकड़ के सर 30-35 मिनट पकड़ लो सर.
Okay, no issues. We will do it in the next lecture. So next lecture, the target would be, मेरा next lecture आपके साथ होगा Monday को. So the target would be, we will be covering up this back angle, then intercept, x meridian, polaris. ये तीनों cover up हो जाएंगे. And along with it, एक दो और छोटे छोटे topics आएंगे बेटा. Comparison between long bicron and intercept. So side solving will be complete. Okay. So हमारा question number 5 जो है ये cover up हो जाएगा in the next class. And if we get some more time, then we will jump into plotting, staggered and simultaneous observation if we get more time. So that is also one session. So that will complete our question number 6. So that's the plan going ahead.
Okay. So just one small, I'm sorry I'm disturbing you. So can you give a list of questions which are asked with respect to the planet? Like अभी जैसे कि sun में we will have to study meridian altitude, azimuth amplitude, long bicron, intercept, x meridian. वैसे stars, planets और moon का भी बताएंगे आप, क्योंकि everything I don't think so they will ask in the exam. So that we can tick mark or you can write down. At least idea रहेगा कि क्या पूछेंगे.
बेटा जो ये मैं मेथड आपको करवा रहा हूँ ना, हमने 2 मेथड किए हैं अभी, मरपास और लॉन्ग बाइक्रोन. ये दोनों मेथड चारों के चारों बॉडीज के लिए एप्लीकेबल हैं. सन, स्टार, प्लेनेट एंड मून, चारों बॉडीज के लिए जो मेथड हमने किया है वो बिल्कुल काम करेगा और चारों बॉडीज में से कोई भी बॉडी हमारे क्वेश्चन पेपर में आ सकती है.
Okay. Because second bit में जैसे कि मून का कुछ नहीं था, like there was not so much about moon because उसके थोड़े calculation advanced.
Now everything is there बेटा, everything is there. मून के केस में सिर्फ एक ही डिफरेंस था, that was longitude correction which we did. So otherwise बाकी सब बॉडीज के लिए method is same. So if you want, you can now practice the simple questions which are given in PracNav. For these two methods, आप एक एक क्वेश्चन प्रैक्टिस कर सकते हो, so that will prepare you for the coming sessions. Okay, ये बेसिक आपके क्लियर हो जाएंगे. Do these simple questions. One question should be enough. हाँ, अगर वो एक क्वेश्चन करने में आपको डाउट आए या आंसर मैच ना करे तो फिर दूसरा भी कर लेना. ओके, so till the time you feel confident and comfortable, you practice that many questions, only those many, not more than that. बिकॉज मैं भी आपको एक असाइनमेंट देने वाला हूं, पर जो मेरी असाइनमेंट आएगी वो प्लॉटिंग जब हम करेंगे तब आएगी, और उस असाइनमेंट में आपके साइड सॉल्विंग और प्लॉटिंग दोनों के कंबाइंड क्वेश्चंस होंगे. रीजन उसका ये है कि हमारे जो क्वेश्चन नंबर 5 और 6 हैं इनमें कॉम्बिनेशन भी आ जाता है. सो नो यूज गिविंग यू द असाइनमेंट because there may be a combination and you may struggle. So when we next session, most probably when we enter into the plotting part, then I'll send you the assignment. Okay.
Okay sir, thank you.
Okay. आज के लिए मैं आपको एक और होमवर्क दे रहा हूं. I am sending you a theory assignment. इसमें कुछ एक थ्योरी के क्वेश्चंस हैं, और इन क्वेश्चंस के साथ मैंने प्रिंसिपल्स ऑफ नेविगेशन जो हमारी बुक है उसमें इस क्वेश्चन का आंसर कहाँ पे लिखा हुआ है, कौन सा पेज, कौन सा टॉपिक, कौन सा पैराग्राफ, वो भी मेंशन कर दिया है. सो इसके थ्रू आप यू जस्ट गो थ्रू ओवर द वीकेंड, यू कैन गो थ्रू दीज थ्योरी क्वेश्चंस, so that will prepare you if any theory question comes in part C, so that will take care of that.
Okay sir, so like these are past questions which have been asked, so the answers are there. Okay sure.
Right बेटा, बोलो बेटा.
सर आपने बताया था कि जो LMT मरपास सन का है that is for same for every longitude सर. बट सर ऑन जब हम साइट निकालते हैं तो सर LMT मरपास में हम LIT लगा के GMT निकाल के जोन टाइम निकाल के शिपमेंट टाइम निकालते हैं सर मरपास का सर.
That's right.
अगर सर ये सेम है सर एवरी लॉन्ग, तो सर हम स्ट्रेट अवे वो क्यों लेते हैं सर जो उसमें दिया है एल्मनेक में?
बेटा LMT तो सेम है, पर आपका शिप जो है वो LMT मेंटेन नहीं कर रहा ना, वो तो शिप्स टाइम मेंटेन कर रहा है. अब अगर दो शिप हैं और वो दो अलग अलग टाइम मेंटेन कर रहे हैं, मे बी दे आर एट द सेम एंकरेज बट मेंटेनिंग डिफरेंट टाइम्स, तो अकरेंस डिफरेंट टाइम पे हो जाएगी ना.
ओके ओके सर.
ओके
ग्रेट. ऊपर से रशियन कप्तान रहेगा तो और प्रॉब्लम रहता है इन लोगों को टाइम.
ओके, सो मजा आ रहा है बेटा नेविगेशन में?
यस यस.
हाँ सर, बहुत मजा आ रहा
है. यस सर.
ओके ग्रेट. कुछ लोग बोल रहे थे जब हमने शुरू किया था, सम पीपल वर सेइंग कि अभी सब हो गया है, बहुत टाइम हो गया है. सो अब याद आ रहा है बेटा? आर यू गेटिंग ग्राउंड?
यस सर, यस.
हाँ सर, सबसे पहले मैं ही बोला था कुछ नहीं आता, आने लगा सर थोड़ा थोड़ा.
वेरी गुड बेटा, ग्रेट.
होपफुली सर आखिरी बार पढ़ रहे हैं सर इसे.
बेटा ऐसा मत बोलो, एग्जाम पास हो जाए फिर भी पढ़ते रहना. इट मेक्स यू प्रोफेशनली इक्विप्ड एंड इफेक्टिव. सो पढ़ते रहना सारी जिंदगी, एग्जाम पास हो जाएगा, दैट्स अ डिफरेंट थिंग.
यस सर.
Okay, all right. So let's call off for today, beta, and I'll see you in the next class.
Okay, sir.
Okay,
yes,
beta.
Okay,
Bye-bye.
sir. Thank you, sir.
Jai Hind.
Bye, bye, sir.
Bye, bye, beta. Good night. Jai Hind.